everybody, welcome back to the Learn to Get YouTube channel. This channel we look at various topics in healthcare and biology and physiology and explain it. So if you like what you see and you're interested in healthcare and various topics within the biology field, like, subscribe, do what you got to do. Anyway, in this video we're going to be talking about blood types. So a lot of people know about blood types. A lot of people know the different types of blood, A positive, B negative, and so on and so on. But not a lot of people understand what that actually means and why certain blood types can give to other people. Why is O negative known as the universal donor? Why is AB positive the universal receiver? So that's what we're going to learn about in this video. Hopefully all your questions will be covered. First thing we have to do is we have to talk about the biology behind blood to fully understand this concept. So there's four parts of blood, four components. So the first one are red blood cells. They're sort of that donut-shaped cell, or a red cell. They carry oxygen throughout the body. So when your lungs take in oxygen, the oxygen goes into your bloodstream and it's picked up by these little guys and then brought all throughout the body to every cell in your body. And then we have white blood cells. WBC, sort of shaped like that. They're responsible for your immune system. They don't really play a role too much within blood typing, however. So then the next one is platelets, and sort of shaped like that. They're responsible for clotting. So whenever you cut yourself, you don't bleed out, right? Your body's able to heal itself. These little guys are partially responsible for why you're able to heal. And then the last one is plasma. So the plasma is the watery part of your blood. Those are supposed to be like water drops. Right, your blood is a fluid, so everything sort of rests within this plasma, all these three things, and then plus electrolytes and everything like that. So the two main parts we're going to be focusing on are red blood cells and plasma, because those are what's going to determine your blood type. Now we're going to start talking about the determination of the red blood cell and how your blood type is determined. So we're going to completely ignore the negatives and positives. So we're actually only going to be talking about A, B, AB, and then O. So no A negative, no B positive, nothing like that. So that's what we're going to be sticking with now. We're going to explain how the negative or positive comes in later, just for simplicity's sake. So, as I said, we have our red blood cell, and then we're going to have our plasma. So RBC, and the rest of the space is plasma. Now, each red blood cell has a marker on it. These markers are called antigens. Now, we're going to make this blood cell specifically A. So this is an A blood cell. This person has type A blood. And then, as you can see, I put the A in the circle. Now, because he's A, there's not going to be any B markers, but there's always A and B somewhere within the diagram, whether it's on the cell or in the plasma. So B, antibodies. So A antigen, which is the marker, B antibodies. What do antibodies do? The antibody will actually attack anything that it matches with it. So say if a B blood cell was brought into the system, because they match, this is going to attack that. But since this, there's no matching markers, they're not going to attack it. It's, again, sort of has to do with immune response. So now we're going to talk about type B blood. So I sort of already spoke about that a little bit. But anyway, this is what type B blood would look like. So like I said, the B antigen on the red blood cell, and then you'll have the A antibody. So it's really quite simple, right? So you can get that. That's pretty easy to grasp. Now AB, so if you can guess, A on the red blood cell is the A marker, and the B marker. Complicated stuff, I know. Now, interesting enough, there's always only one marker of each, so you're not going to have a in here or anything like that, or a B. You're actually going to have none. So no actual antibody, no immune response. So that's going to actually come in pretty important later when it comes to blood donations. And now O. So there's no O marker, right? So there's not going to be a marker at all in the blood cell. But they're going to have the antibody within the, oops, that's supposed to be an A, within the plasma. So that would be type O, right? So, yeah, that's the main, lesson to be learned is that there's only two markers. There's A and B. Whether or not it's on the blood cell or if it's in the plasma itself determines on, what type of blood it is. If it's A, there's going to be an A marker. If it's B, there's going to be a B marker. If it's AB, there's going to be A and B, and if there's O, then it's going to be no marker, and then the opposite would be within the plasma. Now that we understand how the letter is associated to the blood type, we're going to be talking about the positive and the negative, so why it's a positive or a negative and what the difference is between those. So technically the last few that I showed you were the negative versions of each of the blood types, because if there's a positive blood type, then it's going to have a positive, it's not an antigen, it's actually a protein on the red blood cell that serves as a marker. But anyway, that's not super important what it actually is. Just know that it's there. So again, we're going to go with A. Let's make this guy A positive. So we're going to make an A. Remember, the B's here, as we all understand. Now we're going to show the positive marker. So boom, just on the cell. So now we know that's A positive. Yeah, so simple as that. Easy, really. So if it were A negative, there would be no marker. You would think that there would be a marker in here, right? Just because if it's not on the blood cell, then it would be in the plasma. For argument's sake, pretend like there is one, because if it were to be exposed to the wrong blood type, then that immune response would happen. But technically, there's no actual marker in the plasma, but there may as well be. Again, so that's really all there is to it. I'm not going to go through each blood type to show you what A or O positive looks like, what B positive looks like, or B negative. So now this portion of the video, we're going to be talking about blood donation and who can give to who, and just using some examples to actually explain how donations work. So as you can see on the left hand side, we have the donated red blood cell. For the sake, it's going to be AB positive, and then the receiver is on the right and he's A positive. So this donation does not work, and it's just like the other example we showed earlier when I was explaining blood typing, or the red blood cells and how they're marked. So it comes down to the receiver and their antibodies. So right here we have the B antibody, right? So it's naturally going to try and attack this. So the A and the B are actually fine, or sorry, the A and the positive is fine, right? Because they both match. But unfortunately, the B doesn't. So because the antibody is going to be searching for the opposite antigen, it's going to destroy that red blood cell, and it won't be usable, and there's going to be a reaction. So an AB positive person would never be donated to A positive person. But what would actually work fine would be a O positive person. So I'll get rid of these. So O positive, so it's going to have just the positive marker, right? And it's going to have the A antibody, and it's going to have the B antibody as well. So let's sort of just scratch those so there's sort of a line between these, so we can it's easier to see. So this one would be fine because the B antibody on the A positive side is going to be looking for its B marker. And it's not there. See, look at it, it's just the positive. So it's going to be fine. That satisfies the body, and the blood donation would go through fine. So this is good. We're happy with that. Now we're going to go through another example. So let's say the receiver is AB positive. And you know what? No, AB negative. So we're going to get rid of this, right? Since it's negative, there's not actually going to be a marker on it, and there's definitely not going to be that B antigen. And let's stick with that same O positive for the sake of simplicity. So we're going to have the A in here still, and the B in here still, and again, the line through. So, as I said earlier, you can sort of pretend like there's this right here, because as soon as this reaction were to happen, if this O positive blood were to be given to this AB negative blood, there would be a reaction. So the body would actually create these and then create those, which would help attack. So there may as well be them there, but it's sort of semantics. So this reaction wouldn't work well because the donated positive antibody would attack the antigen for the O positive. But what if we got rid of the positive and we made it O negative? So if this were O negative, then there would be that in there, and the red blood cell would have absolutely no antigens on it, so nothing would actually trigger a reaction, and this would be fine. This blood donation would be fine. That's actually why O negative is the universal donor. This chart on screen is a chart that says exactly every blood type and says who can give to who. So if you're O positive, it says that you can donate to O positive, A positive, B positive, and AB positive. And if you're O positive, you can only receive blood from O positive and O negative. So I'm not going to go through each and every one just because it's sort of tedious and a waste of time. If you want to pause the video and take a look at the chart, more than welcome. Anyway, a few things I am going to mention is the O negative blood and AB positive blood. So starting with O negative, it says you can give to all blood types. That makes it the universal receiver. Sorry, the universal donor. It's a universal donor. Like I said a few minutes ago, I drew it out, and if you recall, there's absolutely no antigen on that cell, right? There's no positive, there's no A, there's no B. They're all antibodies. So because of that, when it's inputted into another person's body, regardless of their blood type, it's never going to trigger a response. There's nothing to actually trigger it. On the flip side, if you're O negative looking to receive blood, you can only receive blood from O negative because the blood that would be coming in has every single flag, or not every single flag, it has a flag, and the O negative blood has every single antibody. So regardless, even if there's a single flag, doesn't matter what it is, whether it's an A, a B, or a positive flag, it will destroy that. So O negative people are great for donations because they can give to everybody, but if you're looking to receive, you're sort of out of luck. It just makes it more demanding, right? I don't actually know the percentage of the population that has O negative, but regardless, if you're O negative, then if you're interested in donating blood, then it would be great because you're definitely in demand. AB positive, on the other hand, they can only they can only be given to AB positive, right? Because they have every single marker on their cell. So because of that, they're always going to trigger a response in the bodies, other than an AB positive person. On the flip side, because they have every single marker, and actually no antibodies, they can receive blood from anybody, right? Regardless of what blood is put into their body, it's not going to trigger a response. So I guess they're sort of useless in terms of donation because they can only be given to AB positive. I mean, if you're AB positive, obviously you should still donate. But, you know, on the grand scheme of things, they're not one of the most important ones. And I think that AB positive is actually one of the rarer types. Don't know if that's by chance or by evolution. Anyway, so back to O negative. Because it's a universal donor, they actually keep this blood type handy in emergency responding vehicles, so like ambulances. In an incident where somebody's bleeding out and they need a blood transfusion right now, they don't have time to go test the blood to see what's a match. So O negative can be given to all blood types, so they keep it handy. It doesn't matter. They don't have to screen them because of that. Quite handy, actually. When you are to have a blood transfusion in a hospital, they always do type and cross. So they test your type, they cross match it and see what blood types would be compatible, and then that's how they determine what they're going to give you. But I'm not going to really delve into that too much. Just that blood donation is a pretty tedious process, and it's quite technical, and there's a lot to actually be done on the person's part, whoever's giving it, because it is sort of a dangerous procedure in the fact that transfusion reactions do happen. Not often, but they do happen. Anyway, I'm now on a tangent. So if you like what you saw in this video, if you have any questions, don't be afraid to leave a comment. Please leave a like. I'll be going through the comments and answering any questions I can if I'm qualified to do so. Yeah, so like I said, like, subscribe if you're interested. Be greatly appreciated. Hope you have yourself a good day, and I hope you learned something. Thank you.